Number 1, for each situation, write an expression answering the question. The expression should use only multiplication. The first one says a person's salary is $2,500 per month and she receives a 10% raise. What is her new salary in dollars per month? So you can think of this as she's getting 100% of her initial salary, right? Her original salary, she gets 100% of that, and she's getting another 10%. So we can think of her new amount being 110% of her initial amount. And we have to think about it that way because we can't use this plus, right? So we're going to have 2,500. We want 110% of that. And when we write percents as decimals, we divide this by 100. So we get 1.1, or you can put 1.10 if you would like. So we're going to do 2,500 times 1.1, which represents 110% of the original. For B, a test had 40 questions. The student answered 85% of the questions correctly. So how many did they get correct? So we're taking 85% of 40, which means we're just going to multiply 40 times 85%. And remember, 85% as a decimal is 0.85. And if you're unsure of how to turn it into a decimal, remember you just divide by 100, and that will give you the number as a decimal, which is what I did up here too, right? I did 110 divided by 100, and that gave me the 1.1 or 1.10 if you'd like it like that. C, a telephone costs $250. The sales tax is 7.5%. Sales tax is an additional cost. You have to pay the $250 plus you have to pay 7.5% of the cost. So this is another one similar to the first one where we have to pay 100% of the phone and we have to pay an additional 7.5% of the phone. So this means we're paying 107.5% of the cost of the phone. So then we'll be doing the cost of the phone times 107.5 as a decimal, which is 1.075. Again, if you need to do this to figure out what it is with a calculator, you can. It just moves the decimal place back 2 points. So then you end up with that 1.075. Number 2, in June, a family used 3,500 gallons of water. In July, they used 15% more water. Select all expressions that represent the number of gallons of water the family used in July. So if we just kind of think about this before we look at the expressions, remember that we have the 100% that they used in June. So they're using 100% of that. So they're using 3,500 gallons, plus they're using another 15%. So if we think about this, this is 115% of what they used in June. We can also think of this in decimals. So if we divide each of these by 100, 100 divided by 100 is 1. 15 divided by 100 is 0.15, and that gives us the decimal version, of 115% as 1.15. So this one is the percent. This is how we would write 115% as a decimal. So that's just a couple things to think about before you start looking at these problems. So now in part A, they've got the June amount, right? So here's their June amount plus 0.15, which is 15% as a decimal, times that amount. So the June amount plus 15% of it would give us July. That's true. Okay, they're using 15% more in July. So they're taking the June amount and we need 15% of that more. So then this would be the total July. So that's true. 3,500 plus 15 cents? No. Okay, they're not just using 15 cents more. Okay, they're using 15% more. C, they're taking the June and they're multiplying it by 15% less because we're subtracting. So this would be if they were doing 15% less in July, but they're not. They're using 15% more. D is good, right? It uses the 115% as a decimal, that 1.15 that we looked at over here. So that's good. And then E just has it split up like this, which is fine. These are equivalent expressions, so we can do it like this as well. So E would be good also. Number 3, Hans' summer job paid him $4,500 last summer. This summer, he will get a 25% pay increase from the company. Write 2 different expressions that could be used to find his new salary. So one is to look at it as you've got his initial salary that he had last summer, plus we want 25% of that. So 25% as a decimal is 0.025, and we want 25% of the 4,500. So we're gonna have the initial 4,500 plus 25% of it. And remember, 25 divided by 100 gives you that decimal if you need help with that. So there would be one expression. Another one you can do is by just writing the 4,500 and multiplying it by 125% as a decimal. So thinking about that he's getting his 100% back from the previous summer and an additional 25%. So he's really getting 125% of his salary. And then this as a decimal is 1.25. So you can also write it that way. So that's 2 options. There's other options, right? If we looked at if we think about the last example, you could also do it like this. So those aren't the only ways to do it. There could be others. Number 4, a military veteran. Military veterans receive a 25% discount on movie tickets that normally cost $16. Explain why 16 times 0.75 represents the cost of a ticket using the discount. So there's a couple different ways I think you could think about this, and I think that you could explain it. Whoops. So one thing that I think you could do is you could think about the fact that, and let me get this in the right color here. So for part A, you could say if they, the original cost is 100%. So if we subtract 25% from that, we get 75% of the cost is what the veterans have to pay. So we want 75% of the original cost to determine the price. So that's, I think, one way. You could just think about how much do we have to pay. If we're getting rid of 25%, then that means that we're paying 75%. I think another way you could do this is by thinking that you're doing 16 plus 16 times 25%, right? Whoops, not plus, minus, because we're going to subtract 25% of 16. And so then you can think of this expression, and then we could factor out the 16, and we get 16 times 1 minus 0.025, which then is 16 times 0.75. So you could kind of look at the algebra way to do it. So this would be the algebra way to do it. And this would be more just thinking about it kind of more logically, or what does it mean kind of in life, just explaining why if we reduce by 25% that we're still paying 75%. So then part B says a new car costs $15,000. Whoops, I meant to change the color. Okay, costs $15,000. The sales tax is 8%. Explain why this represents the cost of the car, including tax. So again, for this one, I think you can do it both ways here. I think you can do the same thing that we just did here, where you say the original cost is 100%, and we need to add an additional 8% for the sales tax. So we need to pay 108% of the cost of the car. So 15,000 times 1.08, since that's 108% as a decimal. So you could say it like that. I think you could also do that. We want to do 15,000 plus 8% of 15,000. So that additional 8%, and then we could factor it. So you're going to factor the 15,000 and you get 1 plus 0.08, which then is 15,000 times 1.08 when you add those together, and you can see that you get it that way. So again, I think either of these are fine. I don't think you need both of them, but whichever one feels like it makes more sense to you to kind of just explain it with percentages or to mathematically show it. Number 5, the number of grams of a chemical in a pond is a function of the number of days since the chemical was first introduced. The function is defined as f of d equals 550 times 1/2 to the d. What is the average rate of change between day 0 and day 7? So for this, we need to look at what is f of 0. So we'll plug in 0 for d, and we end up with that initial value of 550. We also need to figure out what f of 7 is. So we'll plug 7 into here, and when we do that, we end up with 4.29. So then the average rate of change, we're going to take the day 7 amount minus the day 0 amount, and we'll divide by 7 since that's how many days this represents. And you get about negative 78. So this is saying that the average rate of change is it's dropping by 78 grams per day. So is the average rate of change a good measure for how the amount of chemical in the pond has changed over the week? Explain your reasoning. And I would argue no, because if we look at, and you know that from doing a bunch of these exponentials, right? So if we start here, if this is 550, then after day 1, you cut that in half. Well, then after day 2, now you're going to cut this in half. Then after day 3, you're going to cut this in half. And day 4, and so on. So the change in the beginning here, right, goes from 550 to 275. So this one drops 275 grams in this first day. So then when you get to day, 6 and 7, so from 6 to 7, the drop here is just down 4.3. So it's dropping a ton in the beginning and not very much in the end, because that exponential curve, right, goes like this. Well, not like that, but it drops and it levels out, right? So it starts to level out down here. So it's much steeper in the beginning and less so at the end. So kind of however you want to say that for your reasoning, and your reasoning could be different than mine. You don't have to have the exact same reasoning as mine, but I'll type something out here. So I would say no, because the amount of chemical drops by 275 after the first day. Then between day 6 and 7, it only drops about 4 grams. And so that's why I would say no, right? Like huge in the beginning, I'm just going to put grams in here. So drops 275 grams after the first day, and between day 6 and 7, it really, only drops about 4 grams. So that's not consistent like the average rate of change would suggest. Number 6, a piece of paper is 0.004 inches thick. Explain why this thickness in inches is a function of the number of times the paper is folded. So anytime we have a function, okay, it means that each input gives us exactly one output. So every time we fold the paper, we get back a specific thickness, right? This is the number of times we folded it. This is how thick the paper is. There's not multiple different thicknesses that come back for different folds. If you know the number of folds, we can figure out the thickness. So that makes it a function. So then it says, using function notation, represent the relationship between t and n. That is, find a function f that t equals f of n. So we're going to use f of n being the number of folds. So now think about this. When we fold a paper, so when you fold, it doubles the thickness, right? Because it lays that many more slices of paper on top of itself, right? So it's going to be double the thickness, and that means that our growth factor is 2. So we want to do the initial thickness, or the initial height, right? So 0.004 times the growth factor, which is doubling in this case, and then to the number of folds. So the initial thickness times the growth factor, and then to the number of folds, n. Number 7, the function f represents the amount of medicine in milligrams in a person's body t hours after taking the medicine. Here's the graph. How many milligrams of medicine did the person take? Well, we know that comes from the initial value. Okay, so at time 0, there's 80 milligrams. Write an equation that defines this function. So I'm just going to write that down here. So we've got f of t. So we need the initial value, which we have is 80. And then we need the growth factor to the t power. So we have to figure out this growth factor. So be careful here because this is 2 intervals, right? It goes from 0 to 2. So when we take and divide these, it's not going to be the growth factor right away. So if we think about this in a table, we've got 0 is at 80, and then we know 2 is at 20. So the growth factor, right, multiplies to get to here and then multiplies to get to here. And I'm going to call it B. So we're multiplying by B to get to this 1 at 1, and then we're multiplying by B again to get to 20. So we're actually finding out B squared here, okay, is equal to, and then we take the new one, 20, divided by the original one, 80. So B squared, if we simplify this, okay, divide by 10, 2 and 8 both divide by 2, we get 1/4. We need to square root this because this is 2 growth factors. So the way that you undo repeated multiplication, okay, is by square rooting it, okay, or using a root, in this case, a square root because of this 2. So if we square root this, we get that the growth factor equals the square root of 1, which is 1, over the square root of 4, which is 2. So our growth factor in this case is 1/2. And you certainly can use a calculator for this too. Like you could have done B squared equals 20 divided by 80. You could have typed that into your calculator to get 0.25. And then you could have square rooted this and got that B equals 0.5 and used 0.5 instead of the 1/2. Either way is fine. Then for part C, after 7 hours, how many milligrams of medication or medicine remain in the person's body? So now we're just going to plug 7 into here. So we'll do F of 7. So we'll do 80 times 1/2 to the 7th, and you'll get about 0.625 milligrams remain. All right, number 8 says match all of these equations with the graph of its solution. So one thing when I'm matching like this, one thing I look at is if we have the same kind of type of symbol and that matches the line type, right? So in this one, we've got equal signs under all of these. That means all of these are going to be solid lines. So the line is not going to set the graph apart, because sometimes that helps you narrow down what you're looking at. Well, all of these have solid lines. So then I like to, since these are in standard form, I like to figure out the intercepts. So I like to figure out where's the X going to cross at. And I crossed this out because the Y is 0 on the X axis, right? So the horizontal intercept. So that allows us to just divide by 3 and get the X value. So X equals 12. Then we can do the same thing, but cross out the X. So then we can determine the Y by dividing by 4, and we get that the Y equals 9. And then I'm just going to do this for each of these. So I'll cross off the Y, meaning I'm plugging 0 in for Y. So I'll divide by 12, and I get X equals 3. Then I'll go ahead and plug in 0 for X, divide by 3, and we get Y equals 12. Do that for this next one. So here we're going to divide by 6 to get X equals 6. Plug 0 in for X. Divide by 4. And I just do this for all of them just to see if they're all different. So now we're going to go and just keep doing it, because then if any of them are the same, we're going to have to look at the shading. But if they're all different, it won't matter. So we'll divide by 3 here to get X equals 12. We'll divide by -9 here. So divide by -9 and we get Y equals -4. Divide by 4. We get X equals 9. Divide by -6 and we get Y equals -6. So none of these share the same intercepts. Like they have some similarities, right? Like 2 of them cross X at 12, but then the Y's are different. So all of these have unique intercepts. So we're going to be able to just match up the intercepts, and that'll get us the functions. So let's go ahead and look for this one. And let me just change the color here so that we can identify it over on the graph. So we want to look for where X equals 12, which goes off the graph, and where Y equals 9. So let's look for Y equals 9 first. So we have a 9 here and we have a 9 here, and that's it. So which one of these is going to cross at X equals +12? Well, this one crosses at 6, so that's not right. So this one's going to cross out here at 12. So A goes with number, and this is kind of hard to see, but this is number 2. But I covered it up with my writing here, but this is graph number 2. All right, then the other one that had a 9 was this one right here. So this one had a Y equals 9. So we could look at this one and see, does the X cross at 6 like it's supposed to for this one? Whoops. And this one does cross at 6. So this C equation goes with graph number 4. Then we can look at 3 and 12, right? So X equals 3. So where does X equal 3? And we see X equals 3 right here. And we see that it would be crossing, and we could imagine that it would cross at Y equals 12. So that's graph number 5. We could look at this one and see where X equals 12 and Y equals -4. So look for Y equals -4 here. And you could imagine that it's going to cross at X equals 12. So that's graph number 3. And then that leaves this last one, X equals 9 and y equals -6 to be graph number 1.